Question 1. Which of the following is not a common classification for unmanned aerial vehicles, UAVs, under the U.S. Federal Aviation Administration, FAA, regulations? A small UAV. B. Medium UAV. C. Extra-large UAV. D. Micro UAV. Correct answer, C. Extra-large UAV. Explanation. Under FAA regulations, UAVs are classified into categories based on weight. The classifications include micro, small, medium, and large UAVs. Extra-large UAV is not a recognized category in FAA regulations. A typical classification would be small UAVs, less than 55 pounds, while medium and large UAVs would typically have a larger weight range, but there is no official extra-large category. Question 2. What is the primary advantage of using real-time kinematic (RTK) GPS systems in drone operations? A. Increased battery life. B. Enhanced precision in georeferencing. C. Better video quality during flight. D. Reduction in flight speed. Correct answer, B. Enhanced precision in georeferencing. Explanation. RTK GPS provides high-accuracy positioning by using a base station that sends corrections to the drone's GPS receiver. This system significantly enhances georeferencing precision, especially in applications such as mapping, surveying, and construction. The other options do not directly relate to the benefits of RTK technology. Question 3. Mr. Ramirez is conducting a drone operation for an infrastructure inspection in a rural area. He is flying a small UAV, and the weather forecast predicts light rain with gusty winds in the coming hours. Mr. Ramirez has completed his pre-flight checklist and is about to launch the drone. What should Mr. Ramirez do next to ensure a safe operation? A. Launch the drone immediately, as there is no immediate risk of thunderstorms. B. Delay the flight until the weather conditions improve and reassess the risks later. C. Proceed with the flight, but ignore wind gusts because they are below 10 mph. D. Launch the drone but fly it at a higher altitude to avoid potential wind gusts. Correct answer, B. Delay the flight until the weather conditions improve and reassess the risks later. Explanation. The decision-making process in this scenario revolves around risk assessment and safety. While light rain might not pose a severe risk, gusty winds can affect flight stability, and the forecasted weather conditions could worsen. It is critical to delay the flight until conditions improve, ensuring the safety of both the drone and the surrounding environment. A proper risk assessment would consider these factors. Proceeding with the flight or ignoring wind gusts could result in loss of control or accidents. Question 4. Which of the following is a requirement for obtaining a remote pilot certificate under the FAA's Part 107 regulations? A. Completion of a 40-hour in-person training course. B. Passing a written exam and a flight skills test. C. Being at least 18 years old and passing a knowledge test. D. Submitting a health examination report from a licensed doctor. Correct answer, C. Being at least 18 years old and passing a knowledge test. Explanation. The FAA requires individuals to be at least 18 years old and pass a written knowledge test to obtain a remote pilot certificate under Part 107. The written test covers regulations, weather, airspace classifications, and other operational knowledge. A flight skills test is not required for certification, although the individual must demonstrate operational competency through practical flight experience. Question 5. When conducting operations in controlled airspace, a drone operator must A. Always contact ATC for permission before every flight. B. Never operate in controlled airspace under any circumstances. C. Obtain authorization from ATC or use LAANC to request approval. D. Only fly at altitudes below 400 feet in controlled airspace without needing authorization. Correct answer. C. Obtain authorization from ATC or use LAANC to request approval. Explanation. In controlled airspace, classes B, C, D, and E, the drone operator must obtain authorization from Air Traffic Control, ATC, or use the Low Altitude Authorization and Notification Capability, LAANC system to request airspace access. LAANC is an automated system for faster approvals. Simply flying below 400 feet does not exempt an operator from needing authorization in controlled airspace. Question 6. What is the main purpose of a flight controller in a drone system? A. To manage the GPS coordinates for the drone's flight path. B. To control the propulsion system and maintain flight stability. C. To ensure the drone's cameras are calibrated. D. To store flight data for post-flight analysis. Correct answer. B. To control the propulsion system and maintain flight stability. Explanation. The flight controller is the central system that manages the drone's flight dynamics. It controls the motors to maintain stability, adjust altitude, and navigate. It ensures the drone responds to inputs from the remote pilot and remains stable during flight. The flight controller does not directly handle GPS coordinates or camera calibration, although it may interact with the GPS for positioning purposes. Question 7. Which of the following is a critical step in the post-flight procedure? A. Inspecting the drone's battery for any signs of damage. B. Analyzing the data immediately to create a report. C. Immediately preparing for the next mission without review. D. Checking the weather forecast for the next day's flight conditions. Correct answer. A. Inspecting the drone's battery for any signs of damage. Explanation. Post-flight inspections are essential to ensure the continued safety and reliability of the drone system. One of the most important checks is inspecting the battery for any damage, swelling, or other issues that may arise from flight. This helps prevent dangerous situations in future flights. Preparing for the next mission without reviewing the previous flight or analyzing data is not recommended, as it could lead to overlooked issues. Question 8. Which of the following statements regarding airspace classifications is true? A Class A airspace is usually reserved for UAVs to operate autonomously, without coordination with ATC. B. Class E airspace can be used for UAV operations without special permissions when under 400 feet. C. Class C airspace is designated for UAV operations with ATC coordination only when above 500 feet. D. Class B airspace requires specific clearance for all drone operations, regardless of altitude. Correct answer. D. Class B airspace requires specific clearance for all drone operations, regardless of altitude. Explanation. Class B airspace, which typically surrounds major airports, requires specific clearance for all drone operations, regardless of altitude. Drone pilots must obtain ATC authorization before flying in this airspace. Class E airspace, in contrast, can be used for UAV operations under 400 feet without special permission, but coordination is required if higher altitudes are necessary. Question 9. What is the primary purpose of using geofencing in drone operations? A. To ensure drones fly only in authorized airspace. B. To automatically trigger emergency landing protocols. C. To calculate the optimal flight path. D. To monitor the battery life during flight. Correct answer. A. To ensure drones fly only in authorized airspace. Explanation. Geofencing is a technology used to create virtual boundaries that restrict or control drone movements. It ensures drones fly only in authorized areas, helping to prevent them from entering restricted airspace, such as around airports or no-fly zones. This is a key safety feature to comply with regulations and avoid accidents or violations. It does not trigger emergency landings or calculate flight paths. Question 10. Which of the following is not part of a standard pre-flight checklist for drone operations? A. Ensuring the drone's battery is fully charged. B. Verifying that the drone's firmware is up to date. C. Confirming the drone's GPS signal is locked. D. Reviewing the drone's maintenance history for the last 12 months. Correct answer. D. Reviewing the drone's maintenance history for the last 12 months. Explanation. While reviewing the drone's maintenance history is good practice for long-term safety and operational integrity, it is not typically part of a standard pre-flight checklist. The pre-flight checklist usually involves checking that the battery is fully charged, the firmware is updated, and the GPS signal is locked, ensuring the drone is ready for safe operation. Question 11. Which of the following best describes the operation of UAVs in controlled airspace, Class B, C, D, or E? A. UAVs are restricted from entering controlled airspace under any circumstances. B. UAVs must be operated with ATC authorization, and remote pilot certification is required. C. UAVs can operate in controlled airspace without special permissions if they are under 200 feet. D. UAVs require a waiver to enter controlled airspace and can operate up to 500 feet. Correct answer. B. UAVs must be operated with ATC authorization and remote pilot certification is required. Explanation. UAV operations in controlled airspace, classes B, C, D, or E, are regulated to ensure safety. According to FAA Part 107 regulations, UAVs must be operated with ATC authorization, particularly in Class B, C, and D airspace, which includes airports. The remote pilot certificate is required to fly within these areas, ensuring the operator understands airspace restrictions and safety protocols. It's critical to obtain the necessary clearances and follow air traffic control instructions to avoid accidents and disruptions in manned aircraft operations. Question 12. What is the primary function of LiDAR sensors in drone operations? A. To capture high-resolution thermal images for temperature analysis. B. To measure distances by emitting light pulses and mapping the terrain. C. To provide real-time video streaming of the area below the UAV. D. To collect multispectral data for vegetation analysis. Correct answer. B. To measure distances by emitting light pulses and mapping the terrain. Explanation. LiDAR, light detection and ranging, uses laser pulses to measure the distance to the Earth's surface and objects, allowing drones to map the terrain in high resolution. This technology is particularly useful for creating 3D models, topographic maps, and conducting precision surveys. It provides more accurate elevation data compared to traditional photography-based methods. LiDAR is widely used in areas such as forestry, archaeology, and infrastructure inspections. Question 13. Mr. Cooper is planning a drone survey for a construction site. The site is located near a heliport, and he is concerned about airspace restrictions. What should he do before proceeding with the mission? A. Mr. Cooper can proceed with the flight as long as the drone stays under 200 feet. B. Mr. Cooper should apply for a waiver or airspace authorization to fly in the vicinity of the heliport. C. Mr. Cooper should fly at night to avoid the airspace restrictions. D. Mr. Cooper can operate without restrictions because he has a remote pilot certificate. Correct answer. B. Mr. Cooper should apply for a waiver or airspace authorization to fly in the vicinity of the heliport. Explanation. Airspace around heliports is controlled to avoid interference with manned aircraft. Under FAA regulations, Part 107, Any flight near a heliport requires prior authorization. Mr. Cooper must either apply for a waiver or request airspace authorization through the FAA to ensure that his drone flight does not pose a hazard to nearby aircraft. Even with a remote pilot certificate, he must comply with airspace regulations, including the requirement for authorization in controlled airspace. Question 14. What is the main benefit of using RTK, real-time kinematic, GPS systems in drone operations? RTK systems allow drones to fly longer distances without losing signal. B. RTK systems provide higher accuracy in geospatial data collection and mapping. C. RTK systems help drones avoid collisions by detecting obstacles. D. RTK systems enable drones to operate autonomously without human intervention. Correct answer. B. RTK systems provide higher accuracy in geospatial data collection and mapping. Explanation. RTK GPS systems enhance the accuracy of geospatial data collection by providing centimeter-level positioning. This is crucial for applications such as surveying, construction, and agriculture, where precise location data is necessary. RTK uses a base station to provide real-time corrections to the GPS data, significantly improving positional accuracy. Unlike standard GPS, which can have an error of several meters, RTK can reduce this error to a few centimeters, making it ideal for mapping and surveying tasks. Question 15. What is the primary purpose of the NOTAM, Notice to Airmen system, in relation to UAV operations? To notify drone operators of nearby weather conditions. B. To inform drone operators about temporary flight restrictions, TFRs, or hazards in the airspace. C. To provide updated regulations for international drone operations. D. To issue drone registration reminders to operators. Correct answer. B. To inform drone operators about temporary flight restrictions, TFRs, or hazards in the airspace. Explanation. NOTAM's notices to airmen are issued to inform all pilots, including drone operators, about temporary flight restrictions, TFRs, hazards, or changes in the status of airspace. This could include information on temporary closures due to special events, emergency situations, or military activities. UAV operators are required to check NOTAMs to ensure they are aware of any potential hazards or restrictions before flying. It is an essential tool for maintaining safety and compliance in the airspace. Question 16. Which of the following is a key consideration when conducting BVLOS, beyond visual line of sight, operations? BVLOS operations can be conducted without any special permissions or equipment. B. The drone must have a built-in collision avoidance system to operate BVLOS. C. The operator must maintain a visual observation of the drone at all times. D. BVLOS operations require a waiver or approval from the FAA, along with additional operational safety measures. Correct answer. D. BVLOS operations require a waiver or approval from the FAA, along with additional operational safety measures. Explanation. BVLOS operations allow drones to fly beyond the operator's visual line of sight, which increases operational flexibility. However, under FAA Part 107 regulations, BVLOS flights require a special waiver or approval from the FAA. Additionally, BVLOS operations must include enhanced safety protocols, such as reliable communication links, sense and avoid systems, and proper risk management practices. These measures ensure the safety of manned aircraft and other airspace users during BVLOS missions. Question 17. Which of the following drone payloads is primarily used for environmental monitoring, specifically for assessing vegetation health? A. Thermal sensors. B. LiDAR. C. Multispectral sensors. D. HD cameras. Correct answer, C. Multispectral sensors. Explanation. Multispectral sensors are used to capture data in different wavelengths of light, which is particularly useful for assessing vegetation health. These sensors can detect various bands, such as red, green, blue, and near-infrared, which are used to calculate vegetation indices like NDVI, Normalized Difference Vegetation Index. These indices help identify areas with healthy vegetation, stress, or disease, making multispectral sensors vital for agricultural monitoring, environmental studies, and land management. Question 18. What is the purpose of geofencing in drone operations? A. To automatically land the drone when it reaches its maximum flight altitude. B. To ensure that the drone operates within predefined geographical boundaries to avoid restricted areas. C. To detect and avoid obstacles in the drone's flight path. D. To provide real-time updates on weather conditions during the flight. Correct answer. B. To ensure that the drone operates within predefined geographical boundaries to avoid restricted areas. Explanation. Geofencing is a feature that allows drone operators to define a virtual boundary around specific areas on a map. The drone will not be able to fly outside this geofenced area unless the operator overrides the restriction. This is crucial for avoiding restricted or no-fly zones, such as airports, military zones, or sensitive infrastructure. Geofencing helps ensure compliance with regulations and enhances safety by preventing accidental airspace violations. Question 19. Which of the following best describes the concept of swarming in drone operations? A. Using a group of drones to operate autonomously in a pre-programmed formation to achieve a shared task. B. A safety procedure to monitor drones when flying beyond visual line of sight. C. A method for controlling drones in high winds. D. A type of communication system used for drone telemetry. Correct answer. A. Using a group of drones to operate autonomously in a pre-programmed formation to achieve a shared task. Explanation. Swarming involves multiple drones working together to perform a task autonomously, usually with a shared goal. The drones are programmed to communicate and coordinate their movements without direct human control. This technology is used in fields such as search and rescue, surveillance, and agriculture. It allows for more efficient data collection, coverage of large areas, and parallel task execution, such as mapping or surveillance. Question 20. What type of drone operation requires special consideration for crew resource management, CRM? A. Simple aerial photography missions. B. Long-range, complex survey missions with multiple drones involved. C. Recreational drone flying. D. Single-pilot drone operations under 100 feet. Correct answer. B. Long-range, complex survey missions with multiple drones involved. Explanation. Crew resource management, CRM, is a critical practice in more complex drone operations, particularly in missions that involve multiple drones and longer flight times. CRM focuses on optimizing team communication, decision-making, and coordination to enhance safety and efficiency. In these types of operations, proper CRM ensures that all team members understand their roles, share information, and mitigate risks. This is especially important in missions that require multiple drones or involve complex environmental conditions. Question 21. Which of the following is the main purpose of conducting a pre-flight checklist for drone operations? A. To assess the weather conditions at the site of operation. B. To ensure that the drone has enough battery life for the entire flight. C. To confirm the drone is operating within legal restrictions and airspace guidelines. D. To verify the drone is mechanically sound and ready for safe operation. Correct answer, D. To verify the drone is mechanically sound and ready for safe operation. Explanation. A pre-flight checklist is a vital part of ensuring that the drone is in safe operating condition before each flight. This checklist typically includes verifying the drone's mechanical components, such as the motors, propellers, battery levels, and sensor calibration. It also involves checking the flight controller, GPS, and communication systems to make sure everything is functioning properly. A thorough pre-flight inspection reduces the risk of accidents due to technical failures and ensures that the operator can focus on the mission itself. Question 22. When performing manual drone flight, which skill is essential for maintaining control during high wind conditions? A. Automated flight modes. B. Obstacle avoidance technology. C. Spatial awareness and orientation control. D. Using an RTK GPS system. Correct answer, C. Spatial awareness and orientation control. Explanation. In high wind conditions, manual flight modes require excellent spatial awareness and orientation control. The operator must understand the drone's position in three-dimensional space and make timely adjustments to counteract the effects of wind, such as drift or loss of control. While automated systems and GPS may assist, manual control is crucial to maintaining stability and ensuring a safe landing or flight path. Operators need to anticipate how wind affects the drone's movement and be ready to correct it during flight. Question 23. Which of the following is an example of a data processing technique commonly used in drone-based photogrammetry? A. Edge computing. B. Point cloud generation. C. Multispectral imaging. D. LiDAR calibration. Correct answer, B. Point cloud generation. Explanation. Point cloud generation is a common technique used in photogrammetry to create a 3D representation of a terrain or object from multiple 2D images taken by a drone. By using specialized software, the images are processed to identify common points across different views, resulting in a dense cloud of 3D points. This point cloud can then be used for creating detailed models, measuring distances, and assessing landforms. It is fundamental in fields like surveying, construction, and archaeology. Question 24. Which component of a drone is responsible for maintaining its orientation and stability during flight? A. Propulsion system. B. Flight controller. C. GPS module. D. Payload sensors. Correct answer, B. Flight controller. Explanation. The flight controller is the brain of the drone, responsible for maintaining its orientation and stability during flight. It processes data from various sensors, gyroscope, accelerometer, magnetometer, and makes real-time adjustments to the motors to maintain the desired flight path. The flight controller is essential for controlling the drone's movement, even in turbulent conditions, and ensures smooth and stable operations. Question 25. Which of the following is a key consideration when selecting a drone for crop health monitoring? A. The size of the drone. B. The presence of a high-definition camera. C. The type of sensor for multispectral imaging. D. The number of propellers. Correct answer, C. The type of sensor for multispectral imaging. Explanation. For crop health monitoring, multispectral sensors are essential as they allow the drone to capture images in multiple light bands, such as visible and near-infrared. This data can then be processed to assess the health of crops, identify areas of stress, and make informed decisions for agricultural management. The type of sensor is more critical than the size of the drone or the camera, as multispectral imaging is key to analyzing plant health. Question 26. What is the key feature of UAV systems that enables them to operate autonomously for extended periods in GPS-denied environments? LiDAR sensors. B. Edge computing. C. RTK GPS. D. Radar systems. Correct answer, B. Edge computing. Explanation. Edge computing refers to the ability of UAV systems to process data locally on the drone, reducing reliance on external servers or GPS for operation. In GPS-denied environments, such as indoors or in areas with poor satellite signals, edge computing allows the drone to make real-time decisions based on onboard sensors like cameras, LiDAR, and accelerometers. This autonomy is crucial for applications such as infrastructure inspection and search and rescue operations. Question 27. How does the use of AI and machine learning improve the efficiency of drone operations? A. By enabling the drone to perform automated takeoff and landing procedures. B. By enhancing obstacle avoidance systems in complex environments. C. By automatically adjusting the camera focus during flight. D. By enabling drones to operate autonomously in all environments. Correct answer, B. By enhancing obstacle avoidance systems in complex environments. Explanation. AI and machine learning improve the efficiency of drone operations by enhancing the drone's ability to perceive and respond to its environment. In particular, these technologies are used to improve obstacle avoidance in complex environments, allowing drones to navigate through urban landscapes, dense forests, or other challenging areas. Machine learning algorithms enable the drone to adapt and improve its decision-making processes based on previous experiences, leading to more reliable and efficient operations. Question 28. What is the purpose of conducting a risk assessment during drone operations? A. To determine the optimal altitude for the mission. B. To identify potential hazards and implement mitigation strategies. C. To verify the operational hours of the drone's battery. D. To measure the flight time required for the mission. Correct answer, B. To identify potential hazards and implement mitigation strategies. Explanation. A risk assessment is a critical step in ensuring safe drone operations. It helps identify potential hazards, such as adverse weather conditions, obstacles, or restricted airspace, and allows the operator to implement mitigation strategies. By assessing risks beforehand, operators can minimize the likelihood of accidents or issues during the flight. The assessment should include both environmental and operational factors to ensure a comprehensive safety plan. Question 29. Which of the following is a primary consideration when operating drones in urban environments? A. Proximity to wildlife. B. Availability of ground control points for mapping. C. Managing communication and data transmission in areas with signal interference. D. Ensuring the drone is within visual line of sight at all times. Correct answer, C. Managing communication and data transmission in areas with signal interference. Explanation. In urban environments, drone operators must manage signal interference caused by tall buildings, dense infrastructure, and electromagnetic sources. This can affect the drone's communication with its remote controller and impact data transmission, such as live video feeds or telemetry. It is critical to use technologies that mitigate signal interference and to plan flight routes carefully to avoid areas with poor signal reception. Question 30. Which of the following would be the most likely application of drones using thermal imaging technology? A. High-definition aerial photography for real estate listings. B. Mapping the topography of a mountain range. C. Identifying heat loss in buildings or infrastructure. D. Measuring the size and shape of agricultural fields. Correct answer, C. Identifying heat loss in buildings or infrastructure. Explanation. Thermal imaging is commonly used to identify heat loss in buildings, infrastructure, or power lines. By detecting temperature differences, drones equipped with thermal cameras can highlight areas where insulation is lacking or where heat is escaping, making this technology essential for building inspections, energy audits, and infrastructure maintenance.